Hi. Okay, this is the video for reciprocal of linear function, part 3. Okay, we talk about a function which involving, for example, I have a negative 2 over x minus 3, and you add a 2, right? This is the one that I want to talk about. So let's say you have this type of function, fx equal negative 2 over 1 over 2 over x minus 3 plus 2. So, okay, very simple. So, I'm going to teach you the short way, okay, shortcut of sketching this graph, alright? So, you just focus. So, very simple. The first step will be identify the domain, right? The domain. The x minus 3 should not be 0, right? No matter how, reciprocal function, we look at this function. This is the function that decide the output, okay now? So this is your input. So x minus 3 cannot be 0. So x cannot be 3. Because you put 3 minus 3, you will have 0, right? So if x cannot be 3, so then we know x can be taking any value except x equals to 3. So the domain of f will be, you can accept any value except 3. Alright? Or you just write negative infinity up to 3. You throw the 3, you exclude the 3. And up to infinity. This is the way you identify the domain for a reciprocal function. So number 2, then you need to know the shape of the graph. This is the ideal way of sketching the graph of a reciprocal function. First, you know that x cannot be 3, right? Okay, then you know that the graph should be this way. You see, the graph y and x, right? Y and x. You know that x cannot be 3. So at line 3, the x equals to 3, you draw a line, right? Which is x equals to 3. You know there is a vertical asymptote here. X cannot be 3. So number 2, you know the location of the graph. You have 1, 2, 3, 4, right? So because of this is a negative, you know that fx equals to 1 over x, right? 1 over x, then it will be in this quadrant, right? So if you have fx equals to negative 1 over x, it will be in this, the second and the fourth quadrant. Alright, but provided that the coefficient of x is positive, this is true. I remind you again, this is true when the coefficient of x is positive. But the whole thing here, the 1 over x, the sign is negative, right? Then it will be in these two locations. So for this case, there is a negative here and the coefficient of x is positive. It will be in the second and the fourth. Okay, this section here. So the vertical asymptote is here, and it will be line between these two, right? So so now I know that okay, first the domain x shouldn't be 3, so I draw the line x equals 3. So and the constant here and the plus 2 here for reciprocal function, I'm going to make it short. So the plus 2 here refer to the horizontal asymptote, 1 and 2. So it's refer to the horizontal asymptote. So means is y equals to 2. Y equals to 2. If this is negative 1, then it will be at negative 1. Okay, it depends on what is the number. Right? If positive 10, then you will draw at 10. Right? So you have asymptote vertical, means that the curve won't touch the x equals to 3 and won't touch the line y equals to 2. So actually, without sketching the graph, you already know the range. Range means for the y cannot take what value? You know the x cannot take 3. You cannot take 3. So for the range, you cannot take 2. The shortcut is this. If you see there is a plus 2 here, you draw the horizontal asymptote. And you cannot take 2. Means that negative infinity up to 2 union 2 to infinity. Means the graph won't intersect. Okay, the y line y equals to 2. So to infinity. Okay, then you can start sketching the graph now. It's in the 2 and 4. If you see here, you divide that to 4 parts, right? You have 1, 2, 3, 4. So it means the graph now will be at 2 and 4, right? So you know the graph will be here. It's always true, alright? It will be here, right? So this is your graph. So they will intersect at the y-axis, x equals to 0. So if x equals to 0, if x equals to 0, you will have, when x equals to 0, your value of y will be 2 over 3 plus 2. 3 to 6, 6 plus 2, 7 over 3. So it means they will intersect at, this is your 2, 7 over 3, right? Which is bigger than the 2. So this is the graph for fx equals to negative x over 3. So as you see that the graph along the x-axis, there is only, the graph is everywhere, but it won't meet the line x equals to 3. Means this x cannot be 3. So for range, you see the range, the y value, there is all having the y value except this line, right? They won't touch this line. So means y cannot be 2. Alright? You can write as all the real number except 2. Very simple. Alright? Okay. So now I'm going to give you another question and you pause the video, and you try first and you look at your solution. Okay? Right. Let's continue with this example. Okay, the most simple way of sketching this will be, the first step is you must identify the input that can be accepted. For this case, x plus 2 should not be 0, right? This thing should not be 0. So x should not be negative 2, right? So then you know that x cannot be negative 2. Means all the value of x you can accept. 3, 4, 5, negative 100 can accept, but negative 2 cannot. So means the x is the input, right? You cannot accept only negative 2. So domain is referred to the input, which is the x value. So you can write as negative infinity up to negative 2 union with negative 2 up to infinity, or you can write as all the number except negative 2, right? Okay, so as you see that x cannot be negative 2, then later you go into the technique of sketching the graph. So you have 1, 2, 3, 4. This is your vertical asymptote, your horizontal asymptote. So then you see that positive, right? This will be positive here. So you know that if you have positive 1 over x positive, the graph will be at the first and the third one. So if you have a negative 1 over x, the graph will be on the second and the fourth, right? Now this is positive, and the coefficient for x also positive, right? Also positive, so it will be at 1 and 3, right? The first and the third, the section 1 and section 3. Okay, now straight away sketching the graph. Okay, you're sketching the graph. This is the shortcut, okay, to sketching the graph without overthinking. Alright. So if you dislike thinking, this is your way of sketching the graph. So now very simple. Locate the horizontal, the vertical asymptote, which you cannot be negative 2, right? It should not be negative 2. So x equals to negative 2. It won't they won't intercept the x equals to negative 2. And how about the y asymptote? In the previous video, I've tell you, you look at the number, right, that add it to the reciprocal function, which is negative 2. So means at negative 2 here, at negative 2, the y equals to negative 2. This is referred to the horizontal asymptote, which is, if this is negative 2, I'm going to plot it on the, I'm going to draw the graph y equals to negative 2 on the y-axis. If this is plus 1, and I will draw at 1. Alright, so now I know section 1. This part is for 1. This is for 2. This is for 3. This is for 4. So now you know the graph is in these two sections, right? So very simple. You just sketch. For this, you can just sketch this one. Right? Done. But for section number 1, I think it's better for you to find the y-intercept first. Either one. You want to find x-intercept or y-intercept. Either one is enough. So if you find the y-intercept will be easier. X equals to 0. Right? So you substitute the x with x equals to 0. So when x equals to 0, y equals to 3 over 0 plus 2 minus 2, which is 1.5 minus 2, negative 0.5. Now you know, if you without knowing the graph, you can be simply sketch, right? So now I know that negative 0.5, the y is here. negative 0.5 means they will intercept here. So I know the graph going down and they intercept negative 0.5 and nearer to the line y equals to negative 2, but won't touch the line y equals to negative 2. So range. So without the graph, you actually can read the range as well. If you see there is a negative 2 here, then you know that the range will be negative 2 union negative 2 up to infinity. Means that you cannot accept negative 2. The y cannot be negative 2. And for domain, you look at this. For domain, you look at the denominator. X cannot be negative 2. So for the range, you look at the number here. So which is also negative 2. So this is the domain and range, and this is your graph. Hello? Okay, let's look at this example. Fx equals to 2 over 1 minus x. And what if the fx is 2 over 1 minus x plus 2? What's the difference between the domain for this and the range for this compared to this, right? And the graph, right? The difference here. So, but this question, you have some trick here where the value, if you rewrite this thing, it will be 2 over negative x plus 1, right? So when you're sketching a reciprocal of a linear function, you have to make sure the coefficient for x is positive. So how you can take up before you decide anything, you have to look at the denominator. In the previous video, every video that I discussed previously, all the value of x in the coefficient is positive, but this is negative. So if this happen to be, you have to factorize the negative out. So it will become negative 2 divided by x minus 1. This will be safer. Alright. So you see negative 2 over x minus 1. If you multiply the x, negative x plus 1. Right. So this is your function that you're going to use to sketching the graph. So very simple. To find the domain, you look at the denominator. Not anything but the denominator, for which is x minus 1 should not be 0 and x should not be 1. So your domain of f is any number except 1. Or you can write in interval form, is from negative infinity up to 1 union 1 to infinity. Okay. How about range? Range very simple. As I tell you before, the shortcut is you look at this fx here, right? Without sketching the graph, you see actually they are not adding anything, right? This is plus a 0, you know. Not adding anything, it means plus a 0. Means what? Means the range is any number except 0. We follow the number here. Alright? 0. So means that it's from negative infinity up to 0 and union 0 up to infinity. This is for y. Y value cannot take 0. The shortcut is you look at the number here. Alright? Then you can start sketching the graph. Without sketching the graph, you can find the domain and range. This is a trick. So, okay, let's say you have x and y, right? So you put the, x cannot be 1. So you put 1 as your asymptote. Okay? 1 as your asymptote. And now you have 4 sections, 1, 2, 3, 4, right? If positive, if this positive, the graph will be in the first and the third. If this is negative, it will be in the second and the fourth. So how to decide? That's why before this, I must make sure the coefficient for x is positive by factorize the negative out. Okay, not negative, I move the negative, go above, before I decide which quadrant. This is a trick here. So now you have negative, right? And this is already positive. So it should be follow this. Negative means in the second and the fourth. Okay, section 1, 2, 3, 4. So will be in these 2 sections. So and you know that y cannot be 0, means it won't touch the x-axis. So the graph should be in this section and this one. Alright, and this one. So they will intercept y, means x equals to 0, right? X equals 0. So x equals 0, y equals to 2 divided by 1, you have 2 here, right? So very simple. Okay, if you're not very understanding, you look at this again. What happens if there is a plus 2? Okay, if there is a plus 2, the domain will still be the same because the domain is depend on the denominator, which is the same, right? 1 minus x. Or you can rewrite this. You already rewrite this as negative 2 over x minus 1. This one from here is actually negative 2 over x minus 1 plus with 2. So we look at the denominator. X cannot be 1. X cannot be 1, right? It's the same thing. So the domain not change. Domain does not change. So it's negative infinity up to 1 union 1 to infinity. But the range is changed. Why? Because you see, just now you're adding with 0. Now you're adding with 2. Plus 2 means that fx is equals to 2 over 1 minus x. Just now without, you got no constant here. So that's why y equals to 0. That's why y cannot be 0. But when you see there is a plus 2 here, very simple. The short way is y cannot be 2, right? Y cannot be 2. So the range will be, this is a shortcut without drawing the graph. So it means that negative infinity up to 2 union 2 up to infinity, or any number except 2. Okay, of course the graph will be also different. First, the asymptote x equals to 1 will be the same. Location is the same. But now you have a plus 2 here, right? So means that 2. Then here you draw a line, right? Draw a line. So the graph will be in this part here. Alright, in this part here. So of course the y-intercept x equals to 0. If you put 0, see 0, try if you set x equals to 0, then your y will be equals to 2 over 1 minus 0 plus 2, which is 4, right? 4. If you are very good, you can see what's the difference between these two. What's the difference between these two? The difference is this one plus 0, this one plus with 2. If you see carefully, the graph is actually shifted up, right? From 2, the y-intercept is shifted become 4. And the horizontal asymptote is moved up to 2. So everything is moving up by 2. Alright? So this is the concept that I'm going to share with you. Alright? That's all for all the reciprocal, the technique of sketching the reciprocal of linear function. Alright? Thank you. Hope you understand.